Hi everybody, let us begin by defining GMOs. These are organisms whose DNA has been deliberately modified in the laboratory. In agriculture, genetic engineering allows us to add traits such as pest resistance or improved nutrition that traditional breeding cannot easily achieve, reshaping how we grow and consume food. GM foods sit at the crossroads of science and ethics. Supporters argue they can combat hunger, promote sustainability, and reduce inequality. Critics raise concerns about safety, naturalness, and corporate control. In this session, we will focus on 5 key academic arguments in favor of GMOs. The first theme is nourishment and food security. Here we consider how GM crops might help feed a growing global population. We examine whether biotechnology can provide reliable calories and better nutrition, particularly for communities that are currently food insecure. Our first argument is that GM technology can raise crop yields and create biofortified staple foods. By embedding essential micronutrients into everyday crops, these innovations aim to reduce hidden hunger and directly target nutrient deficiencies in vulnerable populations. Golden rice illustrates this idea. Engineered to produce beta-carotene, it was developed over decades to combat vitamin A deficiency. Recent analyses show hundreds of millions of children lack this vitamin, while over 700 million people experience acute hunger, underscoring the scale of the challenge. Our second theme is human health. We assess whether GM foods are safe to eat. This requires moving beyond public fear and focusing on robust scientific data accumulated over many years of consumption and monitoring in diverse populations. The evidence base indicates that GM foods pose no demonstrated threat to human health. Decades of use have not revealed systematic harms, suggesting that many public concerns are not supported by current scientific findings. A major literature review reports that billions of GM meals have been eaten without documented toxicity in clinical, scientific, or legal records. Long-term comparisons between regions that widely consume GM crops and those that do not show no increase in cancer, obesity, diabetes, or allergies. The third theme is the environment. Here we explore how GM crops can influence pesticide use, soil health, and broader ecological sustainability. The central question is whether specific traits can make farming more resource efficient and environmentally responsible. Some GM crops are designed to lower dependence on chemical pesticides and support more sustainable agriculture. By targeting pests genetically rather than chemically, these varieties can potentially reduce environmental contamination and protect beneficial species. Bt crops are a key example. They incorporate genes from a natural soil bacterium that produces proteins toxic to certain insects but safe for humans. Studies show farms using Bt crops often spray fewer pesticides, improve soil health, and over many decades have seen no major safety issues. Our fourth theme concerns the economy. We consider how GM technology affects production costs, farm incomes, and national food bills, particularly in countries that rely heavily on food imports to meet basic dietary needs. Economically, GM croppers can lower unit food costs and raise production efficiency. Higher yields per hectare mean more output from the same land, which can benefit low-income consumers and ease pressure on economies that spend large shares of income on imported staples. Personal and academic accounts both indicate that cheaper GM foods can stretch limited household budgets. Research also shows that when import-dependent nations adopt GM crops, they may reduce reliance on expensive imports and strengthen their overall food security position. The fifth and final theme is justice and global equity. We ask whether access to GM technology should be viewed as an ethical obligation, particularly when it has the potential to alleviate hunger and malnutrition in less advantaged regions. From a distributive justice perspective, withholding safe, beneficial GM technologies from food-insecure populations can be seen as unethical. Equitable deployment aims to ensure that scientific advances translate into tangible benefits for developing countries. Ethicists argue that ignoring GM solutions where they could reduce suffering conflicts with principles of justice and solidarity. The approval of golden rice in the Philippines, where many children face vitamin A deficiency, shows how regulation can convert scientific promise into real public health gains. This concludes our overview of the pro-GMO arguments across nutrition, health, environment, economy, and justice. The material reflects a curated synthesis of current academic evidence, intended to support informed, critical discussion within your organizations and classrooms.